This is a B3 video from the topic infection and response, looking at immunity and also vaccination. Now we can see from this graph quite a lot of information about antibody levels. Now this graph can be used when we have a first infection and we're gaining that active immunity, the ability to fight that infection again in the future ourselves. It can also be used to show antibody levels when we receive a vaccination. So we can see at the beginning there we've got the first infection. This could be the first time we are exposed to a particular disease, whether that's just come from contact with somebody else or whether that's come from a vaccination. And we can see that the antibody levels rise. Now it's the white blood cells that make antibodies, and those antibodies don't stay around, but the white blood cells, called the memory cells, that have the ability to make those antibodies, they do stick around. Okay, so we can see after the first infection the antibody levels rise, and then after the pathogen's been destroyed those antibody levels drop off again. The second infection is where those memory cells, the white blood cells with the ability to create the correct antibody, start to increase again. Okay, so we've got the antibody level rapidly rises, and that's really important that we can use a word like rapid, fast, quickly, increase those numbers. And the point is that they increase quickly so we don't even know we're ill. Okay, there is that immune response creating those antibodies to fight the disease so that we don't actually get ill that second time. Okay, and that's what we call our immunity. So there's active immunity if we're doing it ourselves, if our body's able to make the right antibodies to fight it in the future, and also active immunity that can be caused by having a vaccination. So it's a really popular graph in exam questions, and that second steep rise is a rapid production of antibodies. So the white blood cells, the memory cells that can make those antibodies, they are there all the time, but the antibodies themselves aren't. They're just produced on demand when they're needed. So we've got some information here about the fact, basically what I've just talked about actually. So if the pathogen enters the body, the white blood cell, known as a lymphocyte, produces the right antibodies for the antigen. The antigen is that part of the pathogen, the protein kind of marker that the antibody then attaches to. More about that in the white blood cells video. It takes a few days to produce enough antibodies to destroy the pathogen, which results in that slight delay before the person feels better. Once a pathogen's been destroyed, a few of those memory cells remain. They are able to recognise the pathogen if it reinfects and make the immune response quicker and more effective in the future. So I've used the phrase active immunity already. Active immunity is about your body being able to respond for itself. Whether that is the response once you've had an infection that you've taken from somebody else, that we've just talked about, or whether it's about a forced active immunity that's occurred from having a vaccine. Okay, now in the vaccine there is a small amount of dead or weakened pathogen, so it can't affect our body in the same way as the real disease would, and it stimulates the white blood cells to make the correct antibodies and then those memory cells, so that in the future the person has that active immunity to fight it. Now sometimes our bodies, even though they're very clever, can't fight for themselves. They can't do that active immunity. So we call this passive immunity. Now the snake bite toxin is very lethal to humans, and so if someone is bitten by particular types of snakes, then they might have to be treated with antivenom. Now antivenom is created using horses. Horses can cope with that snake bite, so they infect the horse with some of the venom from the snake. The horse then uses its white blood cells to make the correct antibodies. We then extract those antibodies and we inject the antibodies themselves into the person who's had the snake bite, and we call this antivenom, okay? And because the person is not making the antibodies for themselves, the horse is making the antibodies, we call it passive immunity. Okay, so the horse can tolerate the snake bite, the person can't. The horse is infected with the snake bite venom. The horse is then able to make the right antibodies. We extract those antibodies from the horse and use them in passive immunity to directly administer antibodies to the person who's been bitten by the snake. So let's have a look in more detail then about what vaccines are. So I said already they contain a small amount of dead or weakened pathogen. This is so that it doesn't infect us and actually make us ill, just enough to stimulate those white blood cells to make the right antibodies. So the antibodies are being made. The white blood cells, we call them memory cells. They have that ability to know how to make the antibodies when they're needed in the future. And then that gives the person the immunity. So let's look at this question then. Why is it that the flu vaccine is administered every year, whereas something like chickenpox, once you've had it, it's very unlikely you'll get it again? And that's because chickenpox doesn't mutate, it doesn't create a new strain each year, whereas the flu, you become immune to one version of the flu, one strain of the flu, and then it mutates. Kind of, maybe we could consider it upgrading, okay? So it creates a new strain, a slightly different mutated version that we're no longer immune to, or we've never had immunity to, and then we've got to train our body in learning how to fight the new version of the flu, the mutated version. So let's have a look at it as a summary. The pathogen mutates, creating a new strain. The new strain is resistant to existing vaccines, and the new strain spreads rapidly because nobody's immune to it. They're all immune to the old version. So if there's no immunity in the community, then it will spread very quickly. The new vaccine must be created and given to vulnerable people. So these are people who maybe have weak immunities, the old, the young, but you can actually pay for the flu vaccine if you want it. You can go and ask for it, and you can pay a small amount of money to have the flu vaccine. That leads us on to herd immunity. This is where you might have your injections at school, and everybody has their injections except maybe one or two people, and those people are relying on everybody else having the injection and them not having it, and they're relying on those people to protect them, okay? Because if most people aren't going to get ill, then there's very few people to pass on that particular disease to the people who haven't had the injection. Herd immunity only works if there's very few people who don't have the injection, okay? So it's where most people have the vaccination, and some people who don't, they're protected by those who did have it. Just some interesting facts. In the United States of America, a child cannot enter school unless they've been vaccinated or obtained an exemption. That exemption could be due to existing medical conditions. In 2008, parents in Belgium were sentenced to prison for not allowing their children to have the compulsory polio vaccination. Now, polio is an interesting one because we don't really have polio anymore. But of course, if we stop vaccinations for polio and other diseases that are very rare, then there's the danger that those diseases will come back. So we need to continue our immunity procedures for diseases like that. And then the last slide here, the benefits and the risks of vaccinations. So benefits: less chance of getting an infectious disease. Herd immunity could wipe out certain diseases. Millions of pounds could be saved on disease treatment, because yes, there's cost involved in vaccinations, but it's a much smaller cost than the treatment of people with diseases. But the risks, there are small chances of harmful or permanent side effects, and those are the reasons really why some people prefer to use herd immunity than having the injections themselves. I hope you found that useful. Thank you.